For so many of us, there's this one moment, usually in middle school, when math just hits a wall. What used to be pretty straightforward suddenly feels like a foreign language. Well, today, we're going to break down exactly why that happens, and I'll show you the simple mental shift that can turn it all around. Does it sound familiar? Yeah, I thought so. If it does, you are definitely not alone. And here's the thing. It's not a sign that you suddenly become bad at math. Nope. It's actually a sign that the game has changed. You're moving out of the world of simple arithmetic and stepping into a whole new landscape, one filled with weird things like negative numbers, variables, and equations. And the old ways of learning just aren't going to cut it anymore. And that right there brings us to the biggest problem of all, what I call the math memorization trap. This is what happens when you try to survive this new, tougher math by just cramming. You memorize as many rules, formulas, and steps as you can, just hoping it'll be enough to pass the next test. But here's the huge problem with that strategy. Just memorizing stuff is incredibly fragile. When you only copy rules without getting what they actually mean, math feels like this giant pile of disconnected tricks. Sure, you might be able to solve one very specific problem, but as soon as the teacher changes the wording just a little bit, you freeze. The whole thing feels like a house of cards, ready to collapse at any moment. So how do you get out of this trap? Well, it all comes down to one simple but absolutely game-changing shift in your focus. It's about moving from just memorizing how to do something to really truly understanding why it works. I'm telling you, this is the switch that turns that confusing wall of rules into a crystal clear connected system. I mean, just look at the difference. Memorization, that gives you a shaky foundation built on isolated rules that you forget almost immediately. But understanding, that builds a strong, flexible network of connected ideas. When you finally get the why, you don't have to try to remember. It just sticks with you naturally. And you can use that knowledge to solve any kind of problem they throw at you. Okay, so let's get our hands dirty and see how this actually works. We're going to unlock the real meaning behind three huge ideas in middle school math, the ones that cause the most headaches. This is where we stop looking at confusing symbols and start seeing real concrete ideas. First up, negative numbers. For a long time, we just think of them as these weird numbers with a minus sign in front. But there's so much more than that. Think of them as a tool that literally expands our world. They let us talk about direction and position, things like temperature below zero, or floors below ground level in a building, or money coming out of your bank account. They give our simple number line two whole directions to go in. Next up, let's talk about variables. The infamous letter X. A variable isn't just a mystery box with a missing number inside. No, it's way more powerful than that. It's a tool for describing a whole relationship or a pattern. For instance, if a notebook costs $2, the little expression 2x describes the cost for any number of notebooks you want to buy. It captures the entire pattern in one tidy little package. And finally, we've got equations. That little equals sign, it isn't just a button that means and the answer is. Think of it like a perfectly balanced scale. It's a statement that the stuff on the left side has the exact same value as the stuff on the right. So solving an equation isn't really about finding x. It's a delicate process of doing the same thing to both sides to keep that balance perfect, until x is all by itself. When you start seeing these symbols for what they really are, you have this big aha moment. You realize that algebra, it's actually a language. It's a super efficient, super logical language for translating long, sometimes messy word problems into clear and simple statements. And you can really see how it all builds on itself. It becomes almost like a translation exercise. The phrase 4 more than a number translates perfectly to x plus 4. 2 less than 3 times a number. That becomes 3x minus 2. See? These aren't random tricks you have to memorize. It's a system. It's a language with grammar. And once you learn that grammar, you can describe almost anything. So after all this, what's the big payoff? What do you get for making this shift from just how to really understanding why? Well, the payoff is huge. It's that math finally starts to feel like a world that actually makes sense. It stops being this long list of boring instructions to follow and becomes a cool system you get to explore. Because that understanding is what gives math its structure, its backbone. All of those little things that felt like completely separate, isolated tricks suddenly start clicking together. You can see how they connect to form one big logical picture. And that scary wall of formulas, it turns into a map that you can actually read and navigate with confidence. All right, so let's wrap this up with the most important takeaways. Number one, math has a why behind every single rule. Finding it is everything. Two, understanding is always, always stronger and more flexible than just memorizing. Three, remember that symbols like X and negative signs aren't abstract, they have real-world meaning. Four, equations are all about balance. And finally, remember that math is a language you can learn to speak, one that describes the patterns of the world all around us. So, I'll just leave you with this question to think about. What really changes for you when math is no longer a set of scary rules to memorize, but a world of incredible ideas to understand? Because once you start asking why, I promise you, everything changes.